what is the issue? In the Netherlands, a couple of years ago, they had an advertisement on the TV. You could swap to green energy tomorrow. It's probably about 3.5% green energy in the Netherlands. But people thought, there is no problem. So this is the difference that, very often we have to persuade the scientists, but the fundamental message, it doesn't matter whether you think that that data is not completely 100% accurate. They don't think there's even an issue, never mind these minute differences that the scientists are talking about. So this is a barrier that we try to remove, because otherwise, we're going to invent, develop a technology, and it's not going to be implemented because the public don't want it. The policy won't be accepted. So we need to get a message across. But it's not just a message. We also need to change, in many situations, change the way people think. That the brain can actually receive nearly 8.9 megabytes of data from the eye in a second when it's visual. But when we're reading words, it's only 81.6 bits of data. So you could almost say it's in our DNA. But your data, your information is only as good as the way you can communicate it. How many of you have seen successful projects or successful pieces of policy that have been communicated in the wrong way? We need to choose the correct way to visualize it. Maybe we even need to create a story in order to get the message across. We have some fundamental building blocks that we need. We need to think about the environment, the perceptions, the culture, the education of the people we're talking to. Are you talking to a scientific attaché? Are you talking to the local school? Are you talking to the citizens in general? What's the public? And what do they do in everyday life? Maybe you can think of an analogy to a certain situation. Communicators also have to dare to go sort of swim against the tide, if you like. In the nuclear world, people are still using this symbol. Basically, you don't need enemies in the nuclear world if you're prepared to use the worst symbol possible to advertise your energy technology. I mean, this is a hazard symbol. This is a danger symbol. So this is the key thing. We have to translate a message that's very complicated very often into something in somebody's life that's far simpler. So you have to think now, how can we get this message across that the chemical composition of a material is changing, or that something is aging? How can you think of an analogy, something that's in their everyday lives, that would allow us to explain that? So we wanted to get the message across that the chemical composition was changing. They didn't have to remember the reaction like in the previous slide. All we wanted the people to remember was, there's some chemicals, some elements, and if you lose one of them, or if you lose others, the material will change. It will have a different property. That's all we needed to get across. We don't need to get a lot of information across, as long as they go away with an understanding that, okay, something's changing in the material, the properties change, so we need to check it. What we also need is scale. You have to put things in perspective. You can tell somebody a number, but if you don't know, relatively speaking, what's a normal value, then you can't compare it. So, what we did, this is colleagues of mine who work in the soil area. They wanted to show how much soil was left in the world fertile enough to grow food to support the population. So they said, okay, this apple is the world. Let's take away the bits of the apple that we can't use. So you take away the oceans, take away the land that can't be used, the land that we've built on or whatever. Then you take away the land that's too hot or too cold. Then you take the land away that's too wet, too dry. And then there's also soil that's been degraded by erosion or contamination or pollution. And in the end, they were left with, relatively speaking, this little piece of the apple. So you've put it into perspective. You could have talked about so many hectares, but they used an apple. What's the key message? We've all been faced with this situation where you have, as a scientist, loads of very, very valuable data. Data that's taken you months, maybe years to produce. Data that also a lot of people need. But these days, also here at the JRC, we're trying to make a culture change where also we decide from this data for certain audiences, what are the key messages that we need to take out. So we have to go from that big pile of data to taking out key facts and then visualizing those. So that in a situation when you're talking to a minister, you have maybe 30 seconds. But if I try to visualize something, I'm going to bring some emotion into it. I'm going to choose an image that I think is most appropriate. And that's difficult. We have to show each time that there's consensus gone into that image. That a lot of different views have been considered and not just your feeling. Here, when we're talking about the increasing population and the strain that puts on our resources, just by using these 4 simple images, you can get that message across without any words, basically. A lot of people understand, basically, if you plug something in, how the electricity gets to your appliance. But what they don't understand is what happens on the other side of the plug. They don't realize that there may be a lot of different forms of energy actually supplying what comes into your house. You can change your message. You can help to educate them. You can explain that we import 50% of our energy. You can explain that wind and sun are fantastic sources of energy, but what happens when the cloud goes across the sun? One thing I'm continually faced with, and any scientists of you will probably recognize this situation, scientists always, or very often, they try to beat the world record to get the number of words and images onto an A0 poster. But when you just need to get a very simple message across to the public or to a politician, why am I doing this? I always use the comparison, when you're rushing for your plane at your national airport, you will pass advertisements like this with very powerful images and very few words. And probably when you get to the pier where your plane is, you'll probably still remember some of those messages. Whereas if that would have been more complex, you wouldn't remember anything. So sometimes we just have to be very abstract. I mean, this pack of cards has got nothing to do with energy. But I think it brings across the message to a lot of people, this is fragile, it can fall down any minute. And one thing I can highly recommend is working with design colleges, but also working with design universities, high schools. This is a project I did with Düsseldorf University. They're pure design students. They know nothing about energy technology. I gave them a talk for an hour and a half on energy technologies. And then we asked them to design an icon for different energy technologies. But the icon had to incorporate the potential of that energy technology. So very interesting, very easy way to get incredibly innovative ideas. But what I'm going to show you here is a video made with an iPhone. I went to a course in London. We had 2 hours lessons. I'd never ever made a film with an iPhone. They gave us an iPhone, a microphone and a tripod. And we had 45 minutes, 2 hours. It was a group of communication people. We split up into twos. We were given 45 minutes to go out in central London, think of a scenario, film the bits of the film, then come back and we had another 45 minutes to mount the film on the iPhone.
Hey, my name is Darren McGarry from London City Council. I'm here today from the London Let's Clean Up the Air campaign. London is slowly grinding to a halt. We have so much traffic every day in London. Okay, it's a problem for traffic, but it's a problem for the environment too. And we have, and now we're putting into place many measures to clean up the environment for future generations.
I work locally. I'm excited that the council's doing more, but we can do more too. I've been encouraging my friends and family to walk more, to cycle and to take the bus instead of the car.
One of the key areas we're trying to promote is what difference can you make to London citizens. Take the bike to the sports school. It's safe in London these days and it's good for the environment. Do you really need the car to take the kids to school? These are some of the many actions that people can do, but we can't afford to wait. We need to take action now.
So that was the first film I've ever made on an iPhone using a microphone and a tripod. You can imagine what the film would look like if you'd done this 10 times. This was when we were trying to explain what a smart grid is. What we wanted to do along with the scientists was to explain what a smart grid is. So we made this touch screen where you could touch on the different elements. You would find out what each element did. And we took the difference down to a very fundamental level, that one, it's smarter, that's why it's called a smart grid, so you have intelligence in there, a lot of IT, whereby the utility and you as a user know far more about how much you're using. And there would be far more storage capacity. And then people could either press on the present or the future, and then they could press on morning or evening. If they pressed on night, then they would see that the wind was still blowing many evenings, so that was producing relatively green energy. Consumption would go down, but the generation was still reasonable. So with this new storage capacity, you could store that. We had a problem that we wanted to show to the politicians. We wanted to show what was the massive potential of energy efficiency. If you just look at one issue, such as data centers, loads of data centers around Europe, most universities or companies have a huge data center. In the past, the data centers were only concerned with keeping your data safe, but they use huge amounts of energy to cool the servers. We at the JRC have been working hand in hand with industry to produce a code of conduct whereby off-the-shelf technology could actually bring the 56 terawatt hours, which all data centers in Europe use, down to 28 terawatt hours. Incredible amount of energy, incredible amount of money. But of course, this is not very understandable to the majority of people. So what we needed to do was to think of a way that we could explain this, to think of an analogy, to think of something else, how we could explain this. We produced an app where indeed you were using this NASA picture of Europe at night. So you had the globe, and the globe turned round and it went dark. And we asked two questions. One question was, how much energy do all the data centers use? So, okay, you had the scientific answer here, went up to 56 terawatt hours. At the same time, the Czech Republic lit up. Because the Czech Republic uses approximately 56 terawatt hours of electricity per year. Not energy, but electricity. Then it went dark, and we asked the second question, how can you reduce this amount of energy? So then we explained about the European Code of Conduct and how much energy could you save. And then the world went dark again, the world turned around, and then Ireland lit up, because this was the amount of electricity. So we're saving the amount of electricity that Ireland uses in 1 year. This is the same in that deforestation is a massive problem. We have a lot of colleagues working on this area. This figure is apparently, according to the experts, what's happening. Again, it doesn't mean much to a lot of people. So the example that we used was a rugby pitch. So basically, that happens every 3 seconds. So everybody can relate to a rugby pitch and 3 seconds. You have reports and you have your data. In an ideal world, you should then discuss with your communication people to decide, okay, what are the messages we want to get across? How do we want to tackle this? What do we want to visualize? And then you have two routes. You can either go the graphical route, graphic designers, or you can go the software route, using programs such as Tableau, Fusion tables, this type of thing, standard pieces of software, which will give you also very nice graphs. So just to give you a few examples, go straight to a concrete example. This is a report. This is a graph from one of our reports. We didn't manipulate it, it's just what it is. We then ask graphic designers to take this graph and present the same data in different ways using graphical techniques. So this is the same data, exactly the same as this. Already, immediately, you can see that wind energy is 20%, whereas on the other, it took 2 glances to say, where is wind energy? You could use this approach, exactly the same data, but you start to put things in perspective. You could use this hierarchical approach, where immediately you've got a message across, if this was your message. This was another graph. Again, very typical graph that probably many of you have used. You could also present it in this way. Or you could say, what are the top 5 countries as far as investment are concerned? You could present it in this way. Exactly the same data. Immediately you see what the countries are, and immediately you see per country what they're investing in different energy technologies. So just by the use of graphic design skills, you can really get your message across in a very powerful way. So I'll now hand over to Francois to give you a little bit of tricks and tips on statistics.
You are a scientist, but you are asked by policymaker to advise them if they should actually stop household surveys and go for this solution, which is about using satellite imagery to estimate poverty. What we are going to discuss is not about the science behind, to understand exactly what is behind. It's just to use the graphics that you have now in your papers, and interpret those graphics in terms of statistical soundness somehow. Are the statistics present there sound enough to trust this paper and to advise to go for that solution? Usually in statistics, if you have this kind of model, you should give what they call the p-value, which is the probability that what you are showing actually is by chance, not by, it's not really what the model is explaining. This probability must be very low if you want to trust your model. So it means that this is a statistic which usually is reported, but here is not reported. But we can excuse them, saying, okay, at least they have reported the coefficient of determination that can give already an idea of the quality of the fitting of the model in terms of statistics. So this information is missing. The second thing is said, we don't have the information about uncertainty, the margin of error around this model. Because if you estimate something, you have to also to say in which range your estimate can vary by chance. In this first graph, remember the paper says that we can predict poverty using satellite imagery. In here they showed what other papers did before. It was to use the night light intensity. It's the image that Darren showed when he was showing the energy efficiency. It's dark, and then we see the illuminated points to estimate poverty. In the past, people do use it. They say that does not work. It's true. But here they show a kind of model that they have fitted to these points. And what we can see here, in terms of statistics, is that this model actually is wrong, because a model should follow at least the points. The line is going in a very strange direction instead of following the points. So from this already you can say this model is wrong. Whatever statistic you can report, this model is wrong. You cannot have a model like this. That is what Mark said before. So it's systematic. The second thing is that the model itself is a counterintuitive, because they're showing something which is strange. You have consumption here, and you have night light intensity here. What we want to predict is the consumption. Usually, what you want to predict should be on the y-axis, not on the x. So it's like this model is predicting night light intensity based on consumption. So it's the other way around. Second, you see that the curve is tending to go down, where it's like saying that night light intensity will diminish when the consumption increase, which does not make sense. So people are getting richer, and they use less illumination. It's strange. So from this point here already you can say, oh, this model is wrong, so I cannot really trust it. Then I can tell my boss, I have really a lot of doubts about the usefulness of this thing. Second, in these graphics, there are things that maybe you do not notice. But the way it's presented here, you have the impression that the correlation between the observed consumption and the predicted consumption is quite good. The correlation looks like good. They go in the same direction, okay? Without looking at the numbers. But actually, look at the axis. The y-axis on the predicted consumption is truncated. It's limited at 10, whereas observed is going up to 20. So if you imagine that this was 20, so you have to have all those points going down, so your actual trend line will be like almost horizontal. Then you don't have the same visual effects that your correlation is good. Whatever you read papers, you read the statistics, be careful. Look at the axis, how they are represented. There are many graphics where the axes are truncated, where they change the scale of the axis to give some impression of high rate growth, something like that. So be careful in reading that. The second thing is ask yourself if what the graphics is presenting makes sense in normal life. Does it make sense? We have the logarithmic scale. So it's not easy to interpret the logarithmic scale. So you have coming from 1 to 20, but 1 to 2 and the 2 to 5, the interval is bigger than from 10 to 20, which is normal in the logarithmic scale. But when you interpret, you have to think about that, because if you pass to the linear scale, things will change completely. You will not have this picture. So here there are a number of things already from these few graphics. If you interpret the statistics correctly, that you can say, okay, I have doubt about this conclusion, and I will tell my boss, no, be careful about following this advice.